Question number 1. What happens at infinite dilution in a given solution? At infinite dilution for a given solution, what happens? That is the question. Yes, so observe the options. The first option, the degree of dissociation is unity for weak electrolytes. For weak electrolyte, degree of dissociation becomes unity at infinite dilution. That is the correct answer. The electrolyte is 100% ionized. That is also correct answer. The electrolyte is taken at infinite dilution, 100% ionized. Actually, for weak electrolyte, degree of dissociation is less than 1. At infinite dilution, there is almost reaches to 1. And the last option, the inter-ionic attraction disappear. Inter-ionic attraction. So cation or anion between ions, attractions disappear. So all answers are correct. That is question number first. So answer is fourth option. Question number 2. In electrolysis of NaCl, when a platinum electrode is taken, then hydrogen is liberated at cathode. While with mercury electrode, it forms amalgam. This is because, yes, by observing the option, one of the options, it is very clear. In the presence of mercury electrode, to reduce H plus ion, more potential is required. So that is why H plus is not reduced in the presence of amalgam. In the presence of mercury, they form amalgam only. Question number 3. As given molarity value is given and volume is given. By using this formula, find out moles. And the question in the given information, half of the moles is taken. Half of the moles means 0.2 by 2, that is 0.1. As you convert into weight, moles into atomic weight 108, then you got weight 10.8. That is the cellular weight given in this formula. By using the formula according to Faraday's first law, W is equal to ECT. W is equal to capital E by 96,500 to C into T. By using this formula, if you find the T, then you got the value 9650 second. It is converted to minutes, that is divided with 60, then you got nearest value, nearly 160 minutes. Question number 4. As we know, according to Faraday's first law, W is equal to ECT. As efficiency is given, current efficiency is 100%, then eta value is taken as 1, then W is equal to ECT, weight by equivalent weight, nothing but moles of OH minus. Moles of OH minus is equal to current is 5 ampere, C is 1, data is 1, T is 965, and substitute here, we got 0.05 moles. By using moles, find OH minus concentration 0.05. pOH is equal to minus log of OH minus, then you got 1.3. Then pH is equal to 14 minus 1.3, that is 12.7. Question number 5. Initially, all Fe plus 3. Question number 5. Initially, all Fe plus 3 ions are converted to Fe plus 2. By supplying current is 0.2 Faraday. 0.2 Faraday. The given iron plus 3 ions are 0.1. By utilizing 0.1 Faraday, 0.1 mole of Fe plus 3 is converted to 0.1 mole of Fe plus 2. Then the remaining current is 0.1 Faraday. To convert to 2 Faraday, 1 mole of Fe plus 2 is converted to iron. Then supplying 0.1 Faraday, how many moles of iron converted? That is 0.05. That is the correct answer. Question number 6. Using electrolytic method, if cost of production of 10 liter of oxygen at STP is rupees X, the cost of production of same volume of hydrogen at STP will be dash. By using this data, we know actually 1 Faraday electricity is passed through oxygen. The volume is 5.6 liters. Suppose 1 Faraday electricity passed through hydrogen, the laboratory volume is 11.2 liters. That means to get the same volume as that of oxygen, that is 5.6 liter, then half Faraday is required. So, if both volumes are same, if the cost is x rupee, the cost of this one is half Faraday only. That is why cost is x by 2. As given 10 liter of oxygen is x rupees, the same volume of hydrogen is liberated, then half Faraday only required. So therefore half of initial money. If it is x rupee, this one is x by 2. That is your answer. Question number 7. For the electrolytic production of NaClO4 based on the equation NaClO3 plus water gives rise to NaClO4 plus hydrogen, the number of Faraday of electricity required to produce 0.5 mole of NaClO4. NaClO4 0.5 moles. Yes, based upon the reaction NaClO3 and NaClO4, the change in oxidation state is plus 5 to plus 7, 2. That means to get 1 mole of NaClO4, the required current is 2 Faraday. To get 1 mole of NaClO4, the current is 2 Faraday. To get 0.5 mole of NaClO4, the required current is how much? That is 1 Faraday. Question number 8. 6 into 10 power 22 electrons. Electrons are used in the electrolysis of metal salt M plus X. 6 into 10 power 22 electron, nothing but 0.1 mole of electrons. That means 0.1 into 96,500 coulomb of electricity. If electricity is this much and the weight of metal is deposited 1.9 and the atomic weight is given 57, then weight is equal to atomic weight by n factor into C into T by 96,500. And substituting here, we got valency of M is X, that is 3. Question number 9. Volume value is given 10 into 10 into 0.1, that is 10 centimeter cube. And density value is given 10.8. By using this data, we can find out mass 108 grams. Then the question, find the moles of electrons required for this process is, as the given plate is silver plate. Silver atomic weight is 108 gram and equivalent weight is 108. So here weight is 108, that means 1 mole of electron is transferred in this process. Question number 10. Dichromate iron is converted to chromic plus 3. The transfer of electrons are 6 per 1 mole. That means passage of electricity is 6 mole of electrons. So given in this problem 1 centimole, 0.1 mole, 0.1 into n factor Faraday first law is equal to Q by 96,500. Then I want to calculate Q value. Then by calculation I got Q value 5790 coulombs. Question number 11. Yes, in the electrolytic reduction of nitroarine with 50% current efficiency of the mass 20.50 grams and the coulomb of electricity is 2 into 96,500 coulomb. Find the molar mass of the compound. Yes, W is equal to equivalent weight, that is molecular weight by n factor into current efficiency into time by 96,500. Substitute all the values in this expression, then we got molecular weight 123. So 123 grams is the answer. Question number 12. Nitrobenzene is converted to aniline. For nitrobenzene given is 1.23 grams nitrobenzene. Yes, 1.23 by 123 is the molecular weight, we got 0.01 mole. For 1 mole of nitrobenzene is converted to aniline, the required electrons are 6 mole of electrons. So for 1 mole, 6 electrons are required. For 0.01 mole, how many electrons are required? So the answer is 0.06. Question number 13. On electrolysis of acidulated water, oxygen liberated is 8 grams, hydrogen liberated is 1 gram. Because oxygen equivalent weight is 8, hydrogen equivalent weight is 1. Yes, the mass of hydrogen is compared Mass of hydrogen is how many times that of oxygen? As the mass of hydrogen is 1 by 8 times of oxygen mass. So then X value is 1 by 8. And volume is considered for 8 grams of oxygen, volume is 5.6 liters at STP. For 1 gram of hydrogen, volume is 11.2 liters at STP. Therefore, volume of hydrogen is 2 times that of oxygen volume. Then ratio of y and x, that is y is 2, x is 1 by 8, y by x, that is 16. Question number 14. Specific conductance value is given. Specific conductance value is given. Lambda m value is given of Ag plus and Cl minus. By using this formula, you can find out molarity. Molarity nothing but solubility. Then solubility product of AgCl is equal to S square, and we got the answer in moles per liter. But the option is given in gram per liter. Therefore, that value is multiplied with 143.5. That is the molecular weight of AgCl. Then we got the answer in gram per liter. That value is 1.9 into 10 power minus 3. Question number 15. Question number 15. NaOH is combined with HCl. NaOH is combined with HCl. 0.1 normal NaOH is combined with 0.1 normal of HCl with equal volume. Then the resultant conductivity, the resultant equivalent conductivity, the conductivity of the resulting solution decreases to value is given 0.0055. Then lambda E is equal to equivalent conductance, the lambda E is equal to K into 1000 by normality. That is the formula. But normality of the salt, how can you calculate? Then acid equivalents are NaBA, base equivalents are NaBB. If these two are equal, then the resultant equivalence is N into V of the salt. By using normality of the salt is equal to a resultant normality is 0.1 by 2. 0.1 by 2 is the resultant normality of the salt. A substitute here, we got the answer 110.